Welcome to Circuit 1B, Potentiometers. This little blue thing in your kit with an arrow on top is a potentiometer. The knob on top can spin freely if you turn it with your fingers. A potentiometer, also called a knob or trimpot, is a variable resistor. When power is applied to the top pin and ground is connected to the bottom pin, the middle pin will output a voltage between 0 volts and whatever the high power level is, based on the position of the knob. Remember our Ohm's law conversation from the last circuit about how voltage is directly related to resistance. Well, a potentiometer uses a special application of Ohm's law called a voltage divider circuit, which you can learn more about by reading the instructional cells in your SIK guide. But at its core, it's just a component that outputs a different voltage on its middle pin based on how far it's been turned. Last circuit, we wrote to digital pin 34 on our board to turn the LED on and off. In this circuit, we'll read from a different pin to see what voltage is on the middle pin of our potentiometer and figure out how far it's been turned. The RedBoard has both digital pins, like pin 34 from last circuit, and analog pins, like pins A0 through A5 in the bottom left of the board, where the A stands for analog. What's the difference between analog and digital pins? Well, digital just means all or nothing. We can either read or write these pins as high to 3.3 volts or low to 0 volts, nothing in between. Analog pins, however, can read continuous values between 0 and 3.3 volts. So we can read 1 volt, 2.5 volts, or any other continuous value from them. This is useful for reading our potentiometer value, which will change in a continuous way as we turn the knob. So we'll be connecting the middle leg of our potentiometer to A0, our first analog input. That's it for theory on Circuit 1B. Now let's build the thing. We'll keep a very similar circuit as Circuit 1A for wiring up our LED with a resistor, and we'll just add this potentiometer with its power and ground pins connected to power and ground of the RedBoard, and its middle leg connected to A0. Notice how, for this circuit, we connect the power and ground of the IoT RedBoard to the power and ground rails on the breadboard. This is a common practice, as often many components in your circuit need the same power and ground, and remember, every hole in a rail is connected. Now let's drive our circuit with code. Similar to the last circuit, these first few cells will be for setup, allowing us to control our LED and access the potentiometer pin. This next cell I'm going to run a couple times. I'll run it once, get a value, and turn the potentiometer, run it again. Finally, let's run the final cell, which will run forever until we stop it with the stop or interrupt kernel button, or we power off and on our board. This cell will read our potentiometer value and blink the LED faster or slower based on where we've turned the potentiometer. And boom, we've completed Circuit 1B. Whenever you're ready, check out Circuit 1C, where we'll use a photoresistor to make a basic nightlight.